When some innovative caveman invented the bow and arrow, it was a huge breakthrough. The discovery turned the Homo sapien into an efficient hunter-gatherer. These days, archery has made a comeback in the hunting community, and it's even been reclassified as an Olympic sport. So you could say the caveman's invention is still right on the mark. Today's bows are definitely not primitive devices. Crafted with calculated precision, they make it easier for you to take your best shot, and the caveman would have been very impressed. To make a longbow, a craftsman cuts 6 strips of cherry wood, a little more than ½ centimeter thick, using a bandsaw. Then with a belt sander, he repeatedly thins the wood strips on both sides, tapering the ends a little each time. The tapering gives the wood some flexibility, which the bow will need to launch arrows into the air. With his bandsaw, he now carves a handle from a piece of wood. Next, he brushes super adhesive glue onto fiberglass strips and the tapered strips of cherry wood. He works swiftly because the glue will start to dry in less than an hour. Now he layers the strips. The fiberglass strips buttress the 6 glued wood strips on either end. This process is called lamination. Next, he glues the wood handle to the fiberglass and wood lamination. And he tops it with a piece of masking tape to protect it from scratches and glue smudges during the next steps. Now the laminates get the squeeze. He places them on a curved plywood shape called a bow form. He positions a steel heat strip, a rubber hose, and another plywood form on top of the laminates. He clamps it all together, then inflates the rubber hose with an air compressor. The pressure from the hose combined with the heat from the metal strip mold the wood to the bow shape as the glue sets. 1 hour later, he removes the laminates, nicely pressed and glued into more bow-like curves. Now he draws the bow form onto the newly curved lamination, following a template made of fiberglass. With his bandsaw, he cuts the wood along the lines he's just drawn. He cuts an arrow shelf. That's the notch for the arrow to rest as the archer aims. Then he trims the handle, making it a little wider at the center for comfort. Next, using a coarse-toothed file, he hollows out little grooves in the upper and lower limbs of the bow. They're called string nocks, and the string will loop around them. To strengthen the tips, he glues little pieces of fiberglass and moose horn over them and the freshly filed nocks. He clamps it in a vice grip to set. When it's dry, he files through the horn and fiberglass to bring back the nock groove. He smooths it with sandpaper. Now he glues another piece of wood over the handle to improve the look and feel of it. He clamps it together while the glue dries, and 3 hours later, he sands it. Next, he wraps the handle in a piece of leather and stitches it together with nylon thread called artificial sinew. Many years ago, they used the tendons of an animal for thread. The leather will make the bow easier to grip. With a gel pen, he writes a serial number on the back of the bow, along with the draw weight. This bow will hold about 20 kilograms of pressure in check when it's drawn. This is a Flemish string jig, a wood fixture with posts on it. He loops nylon string around the posts. This is how he measures the string. It's always 4 inches shorter than the bow. He cuts it with a utility knife, then rolls wax onto it to make it easier to work with. He measures some string. Then he twists 16 strands of nylon, 8 black and 8 white, into a braid with loops on the ends. He hooks the string on the nocks, and it's time for target practice. As he bends the bow, energy is stored. He releases it, and the energy propels the pointed projectile. That apple didn't have a chance.
A pulley is a wheel with a grooved or barreled rim in which you run a rope or belt. It's a simple device used to lift a load that's hard to access or too heavy to move by hand. Pulleys and multiple pulley systems are vital components of many types of machines. These pulleys are designed for use in small to large-scale electric motors. For example, fan belts in the air circulation systems of office buildings, factories, and mines. The factory makes its pulleys from a 50-50 mix of scrap iron and steel. The furnace heats the metal to 1,370 degrees Celsius, slightly above the metal's melting point. Workers adjust the chemical composition by adding carbon and silicon. The right recipe is essential for producing quality metal. In the furnace, the metal's impurities, called slag, rise to the surface. Workers use giant paddles to skim it off. Once the lab analyzes and approves a sample, they transfer the molten metal by ladle to a 30-ton holding furnace. This furnace maintains the metal at a constant 1,370 degrees Celsius, the required temperature for a proper casting. You can't pour metal this hot into a metal mold. The mold would just melt. So instead, the factory uses damp sand. Sand withstands intense heat by absorbing it. The machine forms the molds much the way you'd use a pail to form a sandcastle. It first constructs the bottom half of the mold. This filter will screen out any slag particles the molten metal may still contain, and these cores create empty spaces within a part. Now the machine forms the top half of the mold. They slip a weighted metal jacket around the finished sand mold. This keeps it from collapsing under the weight of the metal. Workers fill the molds right to the top. It takes from 30 to 45 minutes for the molten metal to solidify. They remove the weighted metal jacket, then dump the mold into what's called the shakeout. The vibration breaks the sand mold apart, releasing the metal pulleys. While the pulleys go off to be cleaned, the sand is recycled into new molds. The pulleys are in rough form. They still have to be machined to specifications. A robot places each one under a computerized camera. A visual recognition program guides the robot to position the pulley properly in the various automated tooling machines. The first machine makes the pulley's grooves. The next machine will drill holes in the hub for installing the screws. At the end of the machining process, a gauging system takes precise measurements and guides the equipment to correct any errors. This is a two-part pulley known as a variable pulley because it can run a belt at variable speeds. This tooling machine performs several operations on the male component. It machines the face and outside diameter on one side, then flips the pulley over to make the bore and threads on the other side. The last operation drills holes for two screws that will affix the pulley to the shaft of the electric motor. A touch of lubricant, and the next machine assembles the male and female parts. After setting the proper speed, the user locks the parts in position with a screw.
The earliest written record of a kite tells the story of a Chinese general in 206 BC who flew a kite over a wicked emperor's palace. He marked the line to measure the distance, then reeled it in. His small army then dug a tunnel into the palace courtyard, launching a surprise attack that conquered the emperor. Today's two-line kite, as the name implies, has two lines to pilot it. It can fly nearly 40 meters high. This kite is made mainly of a lightweight nylon fabric that is waterproof and fade-resistant. It's less than 1 millimeter thick, so it's reinforced with nylon mesh to reduce ripping. The kite's other components include nylon and elastic cords and straps, fittings made of leather, rubber, aluminum, and plastic, and carbon rods. The kite maker starts with a pattern made out of pressed wood. She marks out a piece of fabric and, with a few bricks to hold the fabric in place, cuts it diagonally. In sewing terms, that's called cutting on the bias. This will stretch the fabric and help it fly. Next, she cuts more pieces of fabric, this time in a different color. This kite has 8 fabric parts that fit together like a puzzle to create a 2.5 meter wingspan. The kite's left and right sides are mirror images, so there are only 4 different shapes to cut. They range in length from 25 centimeters to 1.2 meters. From start to finish, it takes one worker about 2 hours to make this model called the Dragonfly. First, the kite maker sews the longest part, called the belly, to the other parts. She double stitches with heavy-duty nylon thread to help the kite withstand winds of up to 35 kilometers an hour. She makes tiny incisions along the belly's curved edge so she can fold it and sew in what's called tension line. Tension line is a type of nylon cord she'll sew into all the seams of the kite's lower sections. It'll give the kite some structure and help keep it rigid while airborne. The kite maker secures each line with a knot, which can later be loosened or tightened to adjust the kite's overall tension. The kite maker uses straps made of very durable yet flexible plastic to line the middle and the edges of the wings. The straps strengthen the kite, enabling it to survive crashes into trees and rocks. After all, what goes up must come down. Next, the kite maker sews a piece of leather called a fitting onto the plastic strap. It's made of leather to protect the kite's structural joints, such as the nose of the kite. It gets a leather patch as well. The kite maker uses a serrated saw to cut the 10 carbon rods to size. They're 6 millimeters in diameter and range in length from 18 to 81.5 centimeters. They form the kite's skeleton, and like bones, they're the most likely part of the kite to break in an accident. But if they do break, it's easy to replace them. A variety of molded plastic, rubber, and aluminum fittings serve a dual purpose. They join the rods together and keep them from falling out of their sleeves. Now the kite maker attaches a nylon cord called a bridle to the fitting that joins the rods on the wing's leading edge. The bridle is the kite's rudder, steering the kite to the left or right. The bridle comes off easily if you need to replace the rods. The kite maker now attaches tension lines to 2 plastic components called arrows. They're located at the kite's wingtips. She ties elastic bungee cords through the arrows to hold the tension lines in place. This makes all the fabric parts taut enough to fly. Next, she attaches the bridle to the center rod, the spine of the kite. She inserts the rod into its protective leather pouch at the nose. She inserts other rods into both sides of the wing. These give the wing its curved aerodynamic shape and help the kite stay aloft. Finally, additional rods under the wing provide more structure and support. These rods spread the kite and help keep it open. In the mood for a sky-high experience? For $250, you can buy a handmade model like this one and go fly a kite. The terms casket and coffin are often used interchangeably, but their use as synonyms is no open and shut case. Coffins are actually those 8-sided burial boxes that are narrower at the bottom. Think Dracula. Whereas caskets are rectangular. They can be made of metal, plastic, or wood. Whether the wood is ash, oak, mahogany, or something else, the casket's construction is generally the same. First, they run wood slats through a machine called a molder. This profiles the edges, carving a tongue on one side of each slat and a groove on the other. A worker applies glue to these edges, then positions the slats in a rounded vise that locks the tongues and grooves together. The glue dries in an hour and a half, bonding the slats permanently into a large curved piece. This piece will form the top and long sides of the casket's rectangular cover. To complete the rectangle, a worker now makes a V-shaped cut on each side and glues in a triangular piece of slatted wood. While a press clamps the components tightly together, he secures the end pieces in place with joint fasteners, which are like heavy-duty staples. Now a machine carves a groove into the cover's underside at the midpoint. A worker glues in a wooden piece, securing it with joint fasteners. This piece is called the bridge, and it's the point at which the cover will be cut in half later on. They transfer the casket cover to an automated machine that gives it a rough sanding, then a finer sanding. The next step is to attach a decorative molding to the base of the casket cover. This molding has a groove on the inside into which they'll later tuck the edge of the casket's upholstery fabric. A worker glues a small piece of wood in the groove at the midpoint so the groove won't show when the cover is open. Now he saws the casket cover in two, right through the bridge. Meanwhile, another worker assembles the bottom of the casket called the box. He glues together the sides and applies a bottom molding, securing everything with joint fasteners. At this point, the box is upside down. He attaches the bottom, then flips the box right side up. Now it's time to join the cover and box using 4 hinges. They spray the casket with one of countless shades of wood stain, then rub it in equally over the entire surface. The casket goes into an oven for an hour to dry the stain. Next, a worker sprays on 2 coats of lacquer with 40 minutes drying time between applications. This happens to be a high gloss finish, but many models have a duller sheen. Once the lacquer dries, a worker attaches handles. The more expensive the casket, the fancier the features. This higher-end oak model with decorative corners has wood and metal swing handles. Other models have all-metal swing handles or fixed bars made of wood, metal, or both. The fancier caskets also have an adjustable wooden bed inside with a mechanism to adjust the height. A worker covers the bed in fabric. The base model bed is made of absorbent paper laid over a product called wood wool, which is simply shredded wood. The upholsterer lines the inside of the casket with foam, covering it with either velvet, satin, or silk polyester crepe. By folding, nailing, and stapling this fabric a certain way, she creates pleats, tufting, and other design details. Generally, the more expensive the casket, the finer the fabric, and the more ornate the upholstery. A decorative trim hides the staples. Fabric straps or metal elbow brackets hold the cover open. When it comes to how beautiful and elaborate caskets can be, the ground's the limit.